So today we're going to be looking at our rational exponent rules. Now, rational is just a fancy word for ratio, and ratio is just a fancy word for fraction. And fractions are actually just another word for division. So if you kind of think about that, let's not overreact of like, oh my gosh, it's ratios. It's okay. We can do this. And the exponent rules, one thing that you're going to see is really nice is that they relate to previous exponent rules that you're already familiar with. So let's go ahead and look at our first example and get this into our notes. So we start off the basic situation of what if I have a base x and a base x that are being multiplied together, but they have a ratio or a fraction as exponents. And the really cool thing is that the exponent rule doesn't change. Just like if I was to multiply any other common bases, that I would end up adding their exponents together. So I'm going to do the exact same thing, but now I'm just adding fractions. So what do you do when you multiply with the common base? You add the fractions. And you add the exponents. So 2/5 plus 1/5 is x to the 3/5. Boom. That is it. This bottom number kind of disappears and it just kind of tags along. And basically you're just doing basic operations with fractions as exponents. So let's look at our next one. Whoa. We got fractions on top of fractions on top of fractions. What are you doing to us? Well, honestly, don't freak out. Because if you remember with our exponent rules, whenever you divide by things that have the common bases, that just means you subtract their exponents. Oh, well then I'm just going to take this exponent and this exponent and subtract them. So again, my base kind of is being tagged along, and now I'm merely looking at applying operations with my fractions. So if this is 3/5 divided by the 1/5 exponent, technically all I'm doing is actually subtracting them. The rule for exponents doesn't change. So 3/5 minus 1/5 is 2/5. That is my answer. Just like that. So all of this simplifies down to that. Alright, so let's look at our next rule. What if I have an exponent with a rational exponent, that is being multiplied or raised to the power, should I say, to another rational exponent? Well, whenever a power is raised to a power, you multiply the powers together. So that rule is going to still apply even though they are fractions. And what do you do when you are multiplying fractions? You simply multiply the numerators across and multiply the denominators across. And that is your answer. So you see an example here that I have x to the 3/4 raised to the 1/2. So all I'm going to do is multiply 3 times 1 and 4 times 2, and I have my answer. Right? So what if I have raised to a negative exponent? Well, whenever it's raised to the negative exponent, you just put the whole thing in the denominator and make the exponent positive. Boom. The rule does not change just because this happens to be a fraction. Same-o, same-o. So what if, though, you end up with some multiple steps? So we're going to do some quick examples of multiple steps. And basically what you see is something like this. Well, first I'm going to do what's inside my parentheses, which means I'm going to end up adding my exponents together, getting my 3/5 x. And then, well, now I'm going to do my power, which just means I multiply them. So when it's all said and done, I simply get 3/20 as my answer. So what do you do when they're multiplied together? You add the exponents. What do you do when it's raised to a power? You multiply the exponents. Same rules, just 2 at a time. So what if you have one that looks like this, and this looks so much more complicated, but just view it as steps at a time and single steps? Well, I had to do what's inside my parentheses first, and here I have 7/8 and a 2/8. Division says, exponent rule says I subtract them first. So, well, 7 minus 2 is 5. My denominator doesn't change. And then when any power raised to a power means I multiply. So 5 times 1 is 5, and 8 times 2 is 16. And I'm done. 2 steps. My hardest things I did was 7 minus 2 and 5 times 1 and 8 times 2. Those are the only operations that I actually did. So last but not least, what if you have something that looks like this? What if I have a fraction or a rational exponent raised to a whole number? Well, my rules still apply both with fractions and exponents. When it's raised to a whole number or raised to any power, I multiply them. Well, how do you turn a whole number into a fraction? Put it over 1. What do you do? When you multiply fractions, you multiply straight across. Now this is where the only kind of step changes and is purely fraction-based knowledge of going, well, if I have 24 over 4, then I can simplify this of 24 divided by 4, and that is actually going to give us 6. Okay? And so my ending answer is x to the 6. And that is it. So those are our exponent rules using rational exponents and some examples of what it might look like when you have multiple steps and simplifying them. All right. I hope this helped.